we're going to do a few more videos and classes on just the schematic and how it relates to the machine. How do you use it for testing? You know, what do you look for? Because you go up to the machine, and one of the hardest things to do was to, say, where do I begin testing? I go up to the machine, I see the machine's not working. What do I test first? How do I come up with that process? Okay, this is what I do first, this is what I do second. And one of the most important things when you're doing that is just first identifying what your problem is with the machine. The machine doesn't fill, the machine doesn't work at all, it doesn't drain, it doesn't spin. Trying to identify those problems before you go to troubleshooting. Identifying those problems, they help you begin your troubleshooting process. So talking to the customer, testing the machine to see if it's doing what the customer says it's doing or what you think it's doing. That's how you're going to begin your troubleshooting process. So again, in the email that was sent out for this class, there is a link to this service manual here that you can download it at your leisure if you haven't downloaded it yet. Let's start off with the diagram and the main control board of the washing machine. If you've seen the videos that I posted on the refrigerator control boards and identifying certain parts of the board, what part is the voltage coming in, what part is controlling the motor, what part is controlling the compressor, where are the sensors located. When they build these boards, they want to separate the boards physically, where all the 120 volt items that we connected to that board will be in one general area. All the low voltage parts that like sensors and stuff like that, they're going to be in another area of the board because they don't want to put 120 volt like up here in the top right corner. We'll put 120 volt here and then put another 120 volt item there because on the board they got to run lines that carry voltage from here to here. So if you can first, just like the refrigerator one, look at a board and identify certain areas and components of the board. Before I even talk about it, I'm going to zoom in on this one picture here, and I want to ask you guys a couple of questions. I'll bring it to the front 1 second here. Okay, so this is not 100% identical. It's hard for me to find a good image of that board, but this is the same board, Whirlpool Duet washer. What do you guys see? Looking at this board, what can you make from just this, just what you see is going on here? Anybody have any ideas?
Besides nothing being connected.
Well, down here they are connected, but like I was just talking, identifying portions or components on the board is very important. So when you're going to do tests, we have to know, where am I testing, what am I testing? In this upper right hand side here that is exposed, it's covered in the bottom right corner here, the same section here where it says upper cover. This cover is on here. You can see these two plastic tabs. Those are the same tabs here. The cover's been removed, but this is the 120 volt side. This is where power is going to come into the main board. And this is got a fuse on here. You know, you're going to put the fuses in an area where the power supply is coming in. Now, what about this? What is this silver or aluminum looking piece? It's in both these pictures here. What do you think that is? Those are heat sinks. And heat sinks are used like in car amplifiers, computer processors, and this is a computer board. You know, it's for a washing machine, but just like the computer, we're all looking at each other on the computer but this is the heat sink here, this aluminum piece right here. Let me identify. This is the heat sink. And the only part on a washing machine control board that's going to use a heat sink is the motor controller. Almost like you would say the inverter board on a compressor. Underneath this, and I'll show you a picture, underneath this is where the switching devices for the motor to go into wash, to spin, and to vary its speeds. This is the motor controller right here. Now what you don't see in this picture is the low voltage section. Underneath this cover right here is a series of plugs, and we're gonna identify them. A series of plugs where our lower voltage components would be. If you look here, it says lower cover down here. That's that same cover, and you can see all these wires in here. So there's a bunch of plugs down in there that are on the board connected to there. And there's also some plugs located here. Now the reason why they got all those covers over them is just so if the washing machine was to leak or someone spilled soap on top of the washer, we try to prevent water or moisture from getting into our electrical connections and causing a problem with our connections and possibly even damaging the board. But let's take a look at the wiring diagram for a second. Now again, hopefully you guys had a chance to download this. Let me move these pictures out of the way. So this is our wiring diagram here, and the neat thing about this diagram, I'll zoom in on it in a minute, that the box right in the middle here, that's this control board right here that we're looking at. So everything on the machine is connected and runs off of that board. So let's take a look close up at this diagram for a second and identify some things. I know it's a little blurry. I got clearer images as we go through, but you can see here areas where it says line and neutral, line and neutral, line and neutral. So what that means is all the components that are connected to the board at those plugs are 120 volt. They're getting line 1 and they're getting neutral directly to that part. Like this blower fan right here, it's a 120 volt blower fan. Baffle solenoid, the water valves, the heater. And there's even components over here that, let me get this out of the way, the heating element for the washer. The door lock mechanism. All these components are high voltage or line voltage, and then other components like this is a fabric softener. Those are low voltage, 5 volts, but make a note that they're also DC voltage. They're not AC voltage. So this is just where it connects on the board. I got some better images where I make it a little bit clearer, but I just want to show that just because they show them drawn like this, like I said, this is all line 1 and neutral, and then we got line 1 neutral on the other side. That does not mean physically on the board, like we said that this area up here is where our 120 volt is. It doesn't mean because these are on the other side that they're possibly on the other side of the board. All they're doing is saying this is the connector, which was a J number, and the pins on that connector, and we'll get to that in a minute. Now, if you guys have any questions as I go, don't hesitate to stop me, but I'm going to just briefly explain the components on there, and then we'll get into how to test from the board and how to test the component. So this is a breakdown of the board, and I rotated the image so it would be laid out the same way this picture would be. And this is out of the book, and it shows you what each plug is and the pin location. Not all diagrams do that. Sometimes the diagram will say, let me just go back, let me go forward here for a second. This here will say J2 is as a connector on the board, pin 1 and 2, but you'd have to say, well, J2, that's J21, I'm sorry, J2, 1 and 2 is right here on the board, where that connector is right on the board. Now, remember I told you that big aluminum heat sink here was for the motor? Well, right here you can't see it, but there's two condensers right here for the motor. And if you look at this box right here, this is J6, 1, 2, and 3. Those are your 3 windings in your motor, and this is the connector right here. That would be this connector right here. And notice that fuse is right there, because that fuse is most likely the fuse that's protecting if the inverter or the motor board, the motor itself shorts out. This will blow the fuse on the power going out to your motor. So that is your connection on your motor. And then all these connectors across the bottom, notice they are a mixture. We have some line 1 and neutral stuff all the way over here, but then on the right hand side, if you look, these plugs here are smaller than these plugs here, and I'll do it in a different color than these plugs here. What is the main difference between those two sets of plugs looking at these boxes down below? They're physically different sizes, right? You want me to rotate the image? I can do that. Hold on one
Yes,
second.
please.
Let me clear that. I'll rotate it and make it larger. Hold on one second. I'm going to rotate it. And let me make it a little bit larger. So hopefully you can read that better. Okay, so what I was saying is we had all these plugs right here. And then we had a different set of plugs, and if you notice, these plugs on the bottom line I just drew, they're a little bit smaller than the plug on the top line. What could you tell me is the difference between those two sets of plugs? The main difference. Gene, I know you're there. You can answer. I'm going to draw a dividing line right here. Because if you look, everything above this line is on the upper plug and everything below this line is on the lower plug. That's a little hint as far as what's the difference between those two sets of plugs.
AC and DC.
AC and DC, yeah.
Very good. So everything on this set of plugs are AC volts, line 1 and neutral. And everything on the bottom set of plugs are DC voltage items. Those are, if you look, you could read a little LED light, our fabric softener switch, and our detergent level switch. That's what SW means. So we have low voltage going through the switch, and all that is just so the board can see if the switch opens or closes. Down here, this is data, ground, VDC. I want you guys to pay attention to HDMI, because one of these next screens coming up, I didn't say, I meant HMI, not HDMI. That's going to come up, and I want you guys to see if you can identify what that was without me telling you what it is. So everything up here, the blower fan, the recirculation pump, the drain pump, this is the actual dispenser as well as this, but these are the switches, okay? This is the dispenser here, and this is the valves that shoot water in for detergent and fabric softener, line 1 and neutral. So this is the valve, and these are the switches here. This one's not being used, and this is a baffle solenoid. I have not seen this exact machine, but a baffle is just like an air dampened refrigerator. It opens and closes, and what Whirlpool decided to do is put some sort of vent at the end of the cycle that would open to help let that humidity and moisture out. I'm sure you all have seen these front load washers with the mold appearing on the gaskets and even the smell people say. So all these manufacturers are doing their best trying to figure out a way to stop this mold and this smell from coming in their machines. I don't know if anybody's been 100% successful, but that's what that baffle is. So let's minimize this for a minute. So since I rotated this, I'm going to just rotate this in the same direction here. So everything here, these components, and I'm going to zoom in a little bit. The dry heater, this is power coming in, line 1 and neutral. This is the heating element for the water. This is our motor. These plugs are the biggest plugs on our board. These are the ones that are going to draw the most electrical current in the machine. So they're a little bit beefier set of plugs. That's why the pins are larger. The lower voltage items and like the water valve and stuff like that, they're not going to draw high amperage, so they don't have to be in such big plugs like this. So again, when you're looking at the pictures or looking at the board, look at these big plugs and you see them all here, and I'll zoom in on it here. They're the ones that are going to be the 120 volt higher amperage components. So now that we just did a little breakdown of the board, anybody got any questions just before I get into more of the schematic and troubleshooting? No? Okay, we'll move on. Okay, so we start off with, let's just say the washing machine does not work at all. So you go up to the washer, you press start, nothing even lights up. So one of the first things you want to do is you want to check power at your plug, and this is your plug right here coming in. And I added this only to show you that looking at these outlets, the main difference on these outlets was the line right here, or the connector right here, has a horizontal tab on it. That actually means it's a 20 amp outlet, and the ones on the left are usually 15 amp outlets. Now, does it make a difference if I put a 20 amp outlet here? No, it'll run. 20 amps will come out of that outlet and the appliance will work. But if it's not rated for 20 amps, what happens is it runs hot. And over a period of time, it gets defective. Okay, so here we have Rfi Filter. We call them line filters. We call them noise filters. These filters are because the motor has an inverter on the board, and we're changing the voltage from AC to DC and controlling that motor with a frequency, changing the frequency of electricity coming in. Here, if you look, our power supply coming in, hertz is what our frequency is, 60 hertz. When you look at your car radio and you listen to channel 100 or channel 96 on your FM radio, that is the frequency. So what the board does is the board takes this 120 volts, 60 hertz frequency coming in, and it raises the frequency, and it raises or lowers the voltage. It converts it from AC to DC. And when you do that to the electrical current in the machine, if you got 60 hertz coming in, remember, just like a washing machine, you have a water hose that brings water in, but you have a drain hose that the water goes out. On an electrical outlet, you have a black and a white wire. The black one is line 1 coming in, and the neutral's coming out. So if I'm going to convert the voltage on this board and change the frequency of the electricity coming off of that board, that's mainly to our motor, that can feed back into the customer's home and cause TVs and radios to get staticky and lose their reception, because you're changing the frequency of the electricity in the home. So the noise filter here is designed to reduce the backflow frequency, almost like a diode only lets electricity go through one way. The noise filter has pieces inside of it that dampen out the frequency that's created by the machine. So we have microwaves and we have washers and other machines that have these high frequency motors here. They have these noise filters on it. Now, if the washer's not working at all, yeah, we could have bad power coming in, but we want to make sure that we have the right amperage here, because if we're running off a 15 amp, this board needs as much amperage as it could to convert for the inverter. So you just want to make sure that the customer has the right outlet and the right breaker if it's running and you're having some issues. Now, if it's not working at all, we check power at the outlet in the wall. Do you guys know which one is line 1 and which is neutral by looking at either one of these outlets? If you look at it, this is one of them and this is one of them. Which one of these is line 1 and which is neutral? I'll say this one's A and this one's B.
B is hot.
Very good. B is line 1 or neutral. And then A is, I'm sorry, line 1 or neutral. It's line 1 or hot, like you said. And then this is neutral. So we call that polarity. And when you're checking polarity, how do you know if this polarity is right in the outlet? How do you test it to say, oh man, the outlet's wired wrong?
You shouldn't get anything on neutral, right?
Well, how do you check just neutral? I mean,
when you go from line 1 to neutral,
Right.
I'm going to have 120. If I go from line 1 to neutral, and I have some meter leads here I could use. Let me just copy this here. 1 second. So I use 2 red ones. It's faster than trying to bring a black and a red one over here. So if I put my meter leads in there, line 1 to neutral, that won't tell me if my polarity is right or wrong by making that test. It'll tell me if there's power and if it's wired backwards, where they put the black wire on neutral and the white wire on line 1, and that's these screws right here. The black screw, the black wire be attached to this screw and the white wire be attached to this screw. If I'm checking right here on the outlet, it doesn't matter whether I put the black meter lead on the left and the red meter lead on the right or reverse them. If there's voltage, I'll have 120. If there's no voltage, I'll have 0. But that's not telling me if my polarity is right. And this is important on some computerized boards and machines. The polarity has to be right. Any guesses?
Put one in the ground and one on the hot.
Very good, Peter. So you're going to leave one on the hot, and you're going to put the other meter lead. I'm sorry, I thought I was moving the other one. So you move this one to ground, and if you have voltage, then it's wired right. If you don't have voltage, go back over here and move your meter lead over here. If you have voltage here, it's wired wrong. So whichever one gives you power to ground is going to be the hot one, and that's how you would tell if the left is hot or the right is hot, by using the ground. Now, if you don't have a ground, use a cold water pipe, like a copper pipe. You could use the screw that screws the cover plate on. If it don't have paint on it, that will also act as a ground and safety. Okay, so let's just move on from here. I didn't want to talk about the outlet too much, but I just want to say we have to have proper power coming in. After that, the power goes into the noise filter, and here's your noise filter right here. And 2 of these are power coming in and 2 of them are power going out. So we got 120 coming in here. You see it says line 1 and neutral. And on the other side, we got power coming out, and it goes to the board, and it goes to J2 on the board. And I'm going to bring that up in the next screen. So our filter here is located underneath the back. Once you move the top, you'll find this in the back, and it's a little hard to see, but right here, this is the power cord. This is the black sheathing around the outside of the wiring for the power cord. It goes through the back wall, and it comes in here. The ground goes to the machine frame, and then 2 wires coming in is our power coming in, and there's 2 more bringing power out. If you look here in our noise filter or line filter, the input voltage is on the bottom here, and the output is on the top. So which one of these are our input output on this one here? I'm going to say A and B. Look at the diagram we have down here. Which one is the input voltage, A or B?
B.
B. All right, so we'll have line 1 coming in one, neutral coming in the other. That's going in, and this is going out. Okay. A lot of people are like, well, why are you making all this big fuss or talking about it? A lot of people look at that line filter and they don't understand what's going on inside of it. They don't know how to test it. All you have to do to check to see if this thing is working properly is B is power coming in. So I'm just going to put 1 meter lead here and here, or on the bottom here, and see if I got 120. Then I'm going to go over here to the plug, which is the 2 on the top here, and check for power out. What if I go to a customer's machine, it doesn't work at all, I have 120 coming in at B, I have 0 at A, that means we changed the noise filter, right? But what if you want to make sure that everything else in the washing machine is working? What could you do when you're testing this and you say, okay, I got power going to my noise filter, I have no power coming out? Noise filter's bad. There's nothing more to it. The noise filter's bad. But, you know, I hate to go ahead and order a noise filter and come back to the customer's house, install it, and the machine's still not working. Now I got to tell the customer, oh, I got to check it more. I might have to order another part. Maybe the main board's bad. What could you do while you're in the home to test the washing machine to make sure, okay, the filter's not letting power out? I'm going to go ahead and see if I can get this washer to run to make sure that everything else is working. What would you do?
Bypass the line filter?
You'd bypass the line filter. How would you do that? Look at the screen. It's there on the screen. Here's the line filter. How would you bypass it? I'll make it bigger. So here's our line filter. So these 2 wires on the bottom are these 2 wires here in the diagram. These 2 wires on top are these 2 wires on the diagram. How would we bypass the line filter? Well, basically we would just take 2 wires, 2 jumper wires, and you strip both ends, and you'll run 1 wire to this one and run wire to that one. Will the washing machine work? All I'm doing is I'm taking this here and connecting it to here with a test wire, and here and here. Basically, I could unplug them from the filter or just leave them there and run 1 wire here, black to black, and 1 wire white to white. Washer's going to run if my filter's my problem. The only thing that'll happen at worst is that if the customer uses it on a spin cycle and they're watching Jerry Springer and it's got all kinds of static on there, they can't see what's going on. So, but you can make sure that everything else in the washer is working, because the last thing I hate to do, especially on a COD job where it's where you're going to make most of your money, is go out there and tell the customer they need 1 part, and then you find out there's something else in the machine that caused that part to fail, and now you need another part, but you already installed it. So a customer says, oh, if it's the main board too, that's too much money. I really didn't want to fix it if it was going to be $500 to fix this washer. You know, you'd want to know that before you left, whether the board was bad or the motor was bad or some expensive part, before you come back with a $20, $30 filter and install it, and then the customer decides, you know, I really don't want to spend that much money. Now you've got to take the filter back out because she doesn't want it, and you're stuck with that part. So you could jump it out and test it, and it'll work just fine. So I brought, let's see, no, it was this picture here that I wanted to say. So this is the outlet. I'm sorry, this is the outlet or the plug coming in. This is the filter, and this is the board. So what would happen is that this is neutral. So neutral is going to go into the board, we said, on the plug here. So we're going to put neutral to one of them. line one to the other. So these two wires right here are these two wires right here. That's the wire going into the filter and going into the filter. And then I'm just going to use a different color coming out. And then these two are going to go into the main board, and we're going to go right to here, line one and neutral, to our main board. We're going to feed our main board its power right there. So if we jump these wires out right here and right here, yeah, the power goes from here right into the board. You're not going to hurt anything. Okay? Any questions on that, the noise filter?
So are we leaving the connections connected, like line output and neutral output connected, and just putting the actual jumper cord or your wire into the actual line output to line input, and then line neutral output to neutral input?
Exactly.
Would it run just okay?
Exactly. You're gonna just make a piece of wire, and you're just gonna jump that out. Now, I wouldn't leave it permanently like that, just in case that wire came loose or whatever. You don't want to start a fire. You definitely want to put the right part back in. But one thing, I'm the type of person that if I find a bad door switch on something, or I find a bad line filter, I try to jump it out to make sure, okay, everything else is working before I leave. That's one of the things I like to do. I want to know that this unit is working. I don't want to just order one part and come back and have to order more parts because I didn't see it operate. Now, you can't do that on everything. If the main board was bad on this, you could not jump out the main board, but could you? I got another question coming up. I'll get to that in a minute. I want to go through this slide. So did that answer your question, Mike?
Yeah, it did. Thank you.
Okay, so there's a door lock mechanism right here. Door lock mechanism, they're not that hard to get to. You can open up the door, and this is a front load washing machine, so you can remove the boot from the front, get right to the lock mechanism without tearing the whole machine apart. But if you wanted to check the door lock from the board, right here is a plug. It says, and I zoomed in on it here, line return, line, and neutral. So that is the 3 pins on the board, and you don't see it here because it's located underneath this cover. Oh, I thought I had a marker. It's located underneath this cover. Remember I told you there's some things hidden. These 2 plugs right here and here are located underneath that cover that I just circled for you. So if we look here to the right, this is the ACU. This is the control board for the washing machine. They call it an ACU. And this is the plug area, J7123, and it's right here. I zoomed in on it for you. You can see it here. Now, if you look, they're showing you J71, 2, and 3. You need to sort of look at the color wires. If you cannot see, somewhere around here, they might put a number 1 telling you this is pin 1. On every plug on the board, there should be an indicator whether it's pin 1 here or this one is pin 1 here, and you count it this way: 1, 2, 3 from the top down, or 1, 2, 3 from the bottom up. But if you can't find that one, look at the diagram. Which one of these on the board is pin 1?
Brown.
Brown. So I just look and say, let's just say it goes exactly like the diagram is. So then let's just say this is brown. The next one should be red, and this one should be yellow. So I could check the door switch from the board, or I could check it from the switch itself. Now this pin 1, 2, and 3 here, if you look closely, here's pin 1, 2, and pin 3 here. That's the pins on the lock mechanism. So this is this, and this is this. And we just have 3 wires going here. 1, 2, 3 inside the washing machine. Any questions about that? All right, so let's go a little bit farther. Now I'm going to come back. Remember I said, can we jump things out for testing? So here's a close-up of the board. here's our lock mechanism, and here's our testing information. Now, just a reminder, this is all from the link that I provided in the email. So if you download the manual, all of this is from the manual. All I did was screenshot stuff, and like this picture of the board in the background, I just zoomed in just to show this one connector here. And here's the plug on the board. So if you're checking the door switch, they want you to check the door switch from J7.2 to J7.3. So if you look here, you could just barely see 2 and 3. You're going to check here and here on the door switch itself, pin 2 and 3. Or you're going to check here, pin 2 and pin 3 here. This will be testing the same 2 pins here. Now, one thing I want you to take notice before you do this, notice that pin 3 on the door lock mechanism here, get my marker, pin 3 on the door lock goes to pin 3 on the board. Make sure some lock mechanisms, you see the board says 1, 2, and 3 here, but the switch may have 1, 2, 3 opposite. But in this case, 3 is 3, 2 and 2 is 1 is 1. You understand there, or did I go too fast? I guess you guys are understanding it. Okay.
Understand.
So if I want to test this, it's telling me with the door open, I get no reading. If I go to the board and I check these 2 pins right here, I'm checking 2 and 3. If I look here, 2 and 3 is red and brown wire coming in. So I got my meter lead here and here on the board. And between 2 and 3, if the door's open, it's open, but when the door closed, I'm getting 60 to 90 ohms. Anybody know why? Now, if you pay close attention to the diagram, I did it on purpose, you could see why you're getting that reading. Read this screen. There's more information on the screen too.
Because you have a closed circuit?
I have a closed circuit, but a closed switch is 0 or infinity. But why am I getting 60 to 90 ohms? Keep reading the screen that I have open. You might be able to see the answer there. The thing is, you know, reading diagrams, you have to be able to look at the diagram for information. And the more you do this, the more it'll just pop right into your face. Because when I tell you, you guys gonna go, what? That's it? That was it? Look at that chart that I have there where I did the first test. What does the third test say? It's a lock solenoid. If we go back to the diagram here, if I go between pins 2 and 3, I'm sorry, I highlighted 1 and 2 last time by mistake. If I go between pins 2 and 3 from the board, this is pin 2 and pin 3, I'm actually going through a switch door and a lock solenoid. When does this door switch close? What actually causes that switch to close inside of this box here?
That's a lock solenoid.
Well, if the switch is open, will the solenoid get power? The switch has to be closed in order for the lock solenoid to activate. So when does that door switch close?
When the door is closed, then.
When the door's closed. There's another switch there in that diagram, right? Between pin 1 and 2?
The lock switch.
Oh, why is one called a door switch and one called a lock switch? The door switch was closed when the door was closed. What do you think closes the other switch? when it locks. So what happens here is when you close the door, you've completed this circuit to the board. The board says, hey, I see the solenoid and I saw that the customer closed the door, and then when I press start, the solenoid can get power, and this dotted line right here, this dotted line means a couple of things. That dotted line that I highlighted means something called mechanically linked. That means when I put power to this solenoid closes that switch. And that's how the washing machine knows that the door is locked. So if you didn't close the door and you press start and it says door on the washing machine, that's because of circuit 2 and 3, it doesn't see that close. Whether the solenoid's bad, opened up, or the switch is bad, it's going to give you a door error saying, hey, close the door. Well, you can ohm it out from the board, or you can ohm it out from the door, but you have to open the door to get in to test it, and it has to be activated by the door itself. You can't remove that switch from the washer and test it on the table. You have to hook it up to that little plastic piece on the door that goes inside of it, and that's the only way it's going to activate. So the better way to test it is to test it, flip this cover over, and there's going to be a plug right there, and you test it from there, from red to yellow. And you're going to get 90 ohms, that means the door is closed. When that happens and you press start, solenoid energizes and closes this. And if, let's just say the door closed, but the lock switch was bad and the washer wouldn't go through its cycle. Well, then you check pin 1 and 2, and you would check to see once the door's locked, and you can hear it click, grab the door to make sure it's locked. Just check to make sure it's locked securely. And then check pin 1 and 2 to see if the lock switch is closed so that the machine can go through its cycle. Now, question time. Can I jump out anything here if I thought the door lock assembly was bad? Can I jump anything out for testing? And what can I jump out and what can't I jump out? Any ideas, gentlemen? All right, well, let me go ahead and tell you, because you're all so wide awake today. So if I jumped out pin 2 and 3, that's line 1 in neutral. That's not good. If I jump that out, I got a solenoid here. I'll create a short circuit. I will damage my board. So jumping things out, you have to know what you're jumping out. Yes?
Can you repeat that, please?
Okay, if I jumped out pin 2 and 3, I can do it from the lock mechanism or I could do it from the board. If I put a jumper from here to here, the jumper, instead of electricity trying to go through the solenoid, the electricity is going to go right to here, and this is line and this is neutral. That'd be like going to this and put a piece of wire in here. What's going to happen? You're going to short circuit. If it goes in and out line and neutral, that's what these two are. So you can't jump out line and neutral. But if we look at this, let's just say, you know, I checked red to yellow and I opened and closed my door. I closed the door, I got 90 ohms. That means what?
The lock solenoid is activated.
Not that the lock solenoid is activated, but the door switch is closed. We are measuring ohms through the lock solenoid, and we have resistance based on the schematic. We don't know if the solenoid's working, but electrically it ohmed out. But if the door switch didn't close, then I wouldn't be able to test here and here. And remember, I'm doing this with the power off and I'm checking continuity. I'll unplug from the board and I'll check the yellow wire and the red wire so I can read through these components here. If I get 90 ohms and I press start and I don't hear my lock mechanism go, maybe the lock is not electrically bad. Maybe the lock got moisture or soap in it and it's corroded and it doesn't want to shift. But you got continuity, you got 90 ohms, so you know that that part of the lock mechanism's good, and you're not getting a door error. Like, it doesn't say door, so your door's not open. But the lock switch is not activating. Can I jump out the lock switch? Can I go from 2 to 1? Like that? Take a guess, guys. If you're wrong, you're wrong.
No.
What'd you say, Peter?
No.
You can. Remember, this is line, and they're saying line return.
Line
So
return.
basically, this is line voltage to feed the solenoid, but this is line voltage coming back. We have no load here. You see this has a solenoid here? If you look at the circuit on the bottom, if you look from red to brown here, do we have a solenoid or a motor or a light bulb or any load in that circuit?
No, just a switch.
Just a switch.
Yeah.
So if I put power on one side of the switch, it's going to be the same power coming out the switch. I can jump out a switch. I can't jump out a motor. I cannot jump out a solenoid. I cannot jump out a heating element. I can jump the switch to the heating element or switch to a light bulb. I can't jump out the motor or solenoid. So yes, I could jump this out. So let's just say I go to the machine, I press start, I see the light light up, I don't hear the lock activate. Okay, maybe my solenoid's bad. I go to the washing machine, I put my meter on J73 and J72, I get 90 ohms. That means two things. It means my solenoid is good because it says there 60 to 90 ohms. And we know that this door switch is good because if the switch was bad, I would not be able to read that. So I've already tested two parts of my door switch. But what if it's not locking? I don't hear it lock. Okay. What would I do to test it? First thing I want to do is I want to put my voltmeter. Did I put it on diagram here? I want to put my voltmeter on line and neutral, which is 2 and 3. I'm going to go back to the diagram here. 2 and 3. And I'm going to press start. I'm looking for 120 volts. Just because it says line and neutral there, that doesn't mean line and neutral is there once the machine's plugged in. It just means that that terminal is the line 1 coming into it, and that's the neutral coming out. There's a relay or a triac on the board. A relay is a triac's electronic relay. There's like a relay on the board that's going to send that power. So line is going to be here, for example, and the only time line will be present is once you press start. So you press start and you put your meter here and here on the board, or we'll say here and here on the board, and it says 120 volts. So my lock solenoid is not engaging. I don't hear it. So if I don't hear it and I have 120, my lock is bad. I've already ohmed it out, and I know that my door switch is good and my solenoid has good resistance. It's not working. I got power. I'm going to change the lock. But you know what? I don't have a lock in my truck. Ma'am, I got to order it. I want to know that that washer is working before I leave. I don't want to order a lock and come back and find out drain pump is bad too, and now I got to go twice. So while I'm here, I'm going to jump out pin 1 and 2 when I press start. That washing machine's going to think the lock is engaged. Guess what? It's going to run. So we could jump out the lock switch, but not the solenoid. So that's how you would check the lock mechanism, and you could run your machine through the whole cycle and make sure that everything else is working before you leave, so that you don't want to say, I'm just going to order the door switch, come back, I got this, the machine's done. Ma'am, that's $275, I'll be back with a door switch. You probably paid $40 for the door switch, you made yourself like $230 on the job, and you're smiling. So jump this out, not that. Any questions? Water level control. Water level control on some of these newer machines, they'll call it a water level sensor. In the diagram, they call it a water level switch. Here they call it a switch, here they call it a sensor. Actually, this is a water level sensor. The switches are mainly found on a lot of our mechanical washers with a mechanical timer instead of a computer board, where when air comes in through the bottom here, goes up, it pushes on a little rubber diaphragm and it hits a switch. Well, a lot of these now are frequency controls. They're not actual switches. So you have to follow the instructions on how to properly test it. So basically the water level switch connects again to the ACU. The ACU was the control board. And how much voltage does that water level switch run off of?
5 VDC.
Correct. And where would you put your meter on the board to make that test?
I would say from 1 to 2.
One says, well, 1 to 2 on the water level switch, or 1 to 2 on the control board?
On the control.
Okay.
Wait,
Go ahead.
from J14.3 to J14.2.
That is correct. You want to do it from volt, DC, and ground. Output is just a communication between the two. You can ohm it out from here to here, just the wire, but you can't really measure anything to test its proper operation. So I would take my meter leads and put 1 meter here and 1 meter here on the board to check for 5 volts DC. Now that's plug J14 pin 2 and 3. So if we look over here, J14 is where on this board? Right here. And pin 2 and 3 would be right here and right here. Now when they write 1, 2, 3, 1, 2, 3, usually they write them in the order in which you physically see them on the board in the picture. So I would assume that this is pin 1 on the left and pin 3 on the right, and this is 1 and 3. This is pin 1 here, pin 3. There is no pin 2 in the middle. So that's how I would check it from the board, because I don't think it's going to be very easy to check on the water level switch, because the plug on them are so small you can't get your meter lead in there. They have those real small plastic container connectors. And I think if you try to unplug it to make a test, it might give an error because the board can't see it. That communication, the output one here on J14.1 would be disconnected, and the board would immediately pop up an error and say, hey, I don't see a wall lever switch, I'm shutting the machine down. So if you want to check it, you check power off the board, but let's look at the instructions for checking the water level switch on the machine. I'm going to go just to the nitty gritty here, where step 12 is. Says, with a voltmeter set to DC, connect your black probe to the control board pin 2 and pin 3 for 5 volts DC. Okay, and that's the one we just discussed. If 5 volts DC is present, replace the water level sensor. But wait, we need to go back and look at the functionality of it here. They tell you step by step how to test it. I'm not going to read that to you, but I'd like you after class maybe to take 5 minutes and just read that page in your book about the water level sensor. And they want you to start and stop the machine. They want you to try a couple things before you do this test. Okay? Now, if VDC is present, replace the water level sensor. But what is happening to make you do that test? If it says, check the functionality of the water level sensor by running a small cycle. The valve should turn off automatically after sensing the correct water level. The following steps assume that this was unsuccessful. So what that means is one of two things is happening. Either no water's coming in at all, or water's coming in, but it's overfilling and flooding the machine. Because they said here, the valve should turn off after sensing the water level. So they're telling you two problems are going to happen. Either it's not going to bring water in, or it's going to flood. So if you had either one of those instances, they want you to check the 5 volts here. Do I need to ohm out my communication wire, the output wire here, J14-1 to pin 3 on the board? Do I need to ohm that out? Probably not, because if there was a connection problem between the top wire here, we'd get an error. The board would shut down. Because if it cannot communicate to that water level sensor, doesn't mean the sensor is good, but if it can't communicate to it, it'll shut down. If you disconnect that plug, try to run the machine, it won't work. It's going to tell you, I can't see the water level switch as a safety device. So they're telling you, if you get 5 volts DC, replace the sensor if you're having these problems. That's it. Because the board only takes information that comes off this output. The voltage coming in on the DC and ground is just sending power to the sensor, so the sensor can read and measure the water level by the air pressure that's going inside of it. So these two are what just supplying power to the board on our sensor, and then that sensor sends a feedback signal to the control board. Now, it says if the preceding steps do not correct the problem, replace the control board. I love that. Say, well, if you got power here, change your sensor. Well, if that didn't work, change the board. Which basically, that happens sometimes. Sometimes you get the right readings and you change the wrong part. You can't always test computer boards. That's the one thing about electronics. I wish all manufacturers were like LG. And the only reason why I say that is because LG usually has one board for everything on the machine. If you start adding more boards, sometimes it's like, is it the main board or the motor control board? How do I know which one of the boards it is? It's hard to tell. But if the motor control board is built into the main board, hey, if either one's bad, you're just changing one board. So that's an advantage of some manufacturers. Whirlpool, a lot of these are made with Samsung. Whirlpool and Samsung are sort of partnered together, and GE and LG are sort of partnered together. GE stresses that they design the machine that LG builds. But it's funny, LG has a dryer that has the same components in them as the GE. So, I don't know. So, I told you a little bit earlier to pay attention to some 3 letters. Do you remember what those letters were? HMI. And HMI is here on this screen. It's called Human Machine Interface, or that's the input, the controls on the board, not the main board, but the controls you're touching to tell the main board what to do. That's your communication to the board. So HMI is your connector here. So we have 2 different versions, Maytag and Whirlpool here. And then this center part is one board, and then your main board is here. This is your input board, and then this is your input and main board are separate. This is just the user interface board here. The main board is on the back of the machine. So let's just say certain buttons are not working. Where does that board connect to this board? If I look here, I'm going to zoom in right here. I just want to show you something. ACU connector. So this is our user interface. And right there on the user interface is where the cable goes to the main board. That's what they're telling you. The ACU is the main control unit. And this is the plug for the control unit on this board versus Maytag versus Whirlpool. Let's take a look at this. Where's it connecting on this board? Just take a minute and read.
I believe J19.
Very good. What made you say J19?
Because of what you said, tune into HMI, and I see it right there.
Very good. That's exactly why I said pay attention to this HMI, because if you were to look at this first, would you know HMI is the user interface? You wouldn't.
No.
So, these are just things like, how do I get this information? If I got the manual, can I can figure it out. So this one plug right here on the board, this one plug right there, that's the user interface. Now, how would I know whether the problem's my main board or the user interface? What could I do? I can make some voltage tests. What voltage tests would I make, and where would I make them? You said J19, right, Mike?
Yeah.
Okay.
I'm looking in between J19.1 and J19.2.
Okay, I'll tell you what I'm going to do is I'm going to rotate it so you guys don't break your neck trying to read it. I'm sorry, I probably should have done that. You guys got to tell me these things. Say, hey, can you rotate that? Okay, so I'm going to zoom in even more. Okay, does that help?
I would look for the both of the voltages coming in
But where would
to
you
see if one's missing.
Where would you put your meter leads? And which one, red or black, goes where? I'm gonna go to another screen for 1 second, and I'm gonna grab my meter leads, and take them over to the other diagram. Hold on. Oops. Let me get the red one. Alright, so where would I put my red and black meter lead, and what am I testing for what?
I would put the black to J19.1 and then go back down and put my red to J19.4 to see if I get the reading from that. If that's good, then I will put my black on J19.2, but leave my red at J19.4 to see if anything is missing from there.
Okay, you're close, but the black is always ground. If you look at your meter, my next time when we're done, get your meter that you use,
Right.
and look at the meter where you plug in your red and black meter lead on the meter. One of them is gonna say COM. Okay.
Yeah.
And the other one's gonna say with a V. It's gonna have an ohm symbol and everything. COM is your ground. Okay. So your black meter lead always goes to that, and your red goes to the V, the ohms, and everything else. So when you're checking voltage, the red is your positive and your black is your negative, just like a car battery. Okay? So I'm going to check 12 volts, and I'm going to also go here, leaving the black meter lead on ground for 5 volts. And again, this one is just a data communication back and forth between the two boards. But if I have those proper voltages, my user interface should work. Now, why do you think we have two different voltages?
One's for data and one's for, what is it for?
I didn't hear you the first words you cut out there, Peter. One's for what?
One's for data.
The difference is the LEDs, the little lights on the board, they run off a different voltage than the communication. You know, like your sensors, your thermistors and stuff, they're all like 5 volts DC. But relays on your board and certain things, they run off of 12 volts DC. LED lights, they run off a little bit more voltage in order for the lights to work. So you're going to make these 2 tests. If you have these 2 tests here, you could, if you want, ohm out the data, which means you'd have to be on the main board, and the other one would be on the main board, and one would be on the user interface, which would be here on this connector right here. And you would go between the wire to make sure that the data wire is good. So you put 1 meter lead here and 1 meter lead here, and check continuity of that. I'm sorry, data to data. J19.3 to J17.3. That you want to ohm out. You cannot check voltages or whatever coming in or out. Here's your ground on the user interface, but your ground's here on the main board. So I would do it for the main board. I'd check 19.1 to 19.4 and 19.2 to 19.4. If I have these voltages and I'm pressing buttons on my user interface, it's not working, most likely my user interface is bad. Okay, if I don't have these voltages, I might have a problem with my main control board. So that was, so far, all those slides took me 2 hours to put together because I have to screenshot and I have to sort of like plan out my lesson and attack it. It did go just over an hour, which is usually our classes are about an hour long. Do you guys have any questions about what we discussed? My next class, I'm going to continue with this manual and these diagrams, but I'm going to go over the motor, the pump, the heating element, the sensors, and the other components in the machine, but I'm going to break them down a little bit at a time. And then the final class, we're actually going to have a Duet washer, and we're going to just do some of the tests live on the board and demonstrate how to do those tests. Do you have any questions from today's class, guys?
What is your main principle for jumping out switches from the board?
Well, the main principle of jumping out switches, just a switch again, Mike. Remember, don't jump out a solenoid or something. Make sure you know what you're jumping out. But if you went to a washer and the lock switch is not testing from the board, you jump out the switch on the board will run. So you could actually see if the machine is working and doing its thing if you jump out the switch. So it's not something you would leave permanently, but you know, would you like to know that if I order this switch, do I know if I come back that this machine's going to work?
Yeah, definitely.
You know, because you don't want to order the switch, takes 2 or 3 days, then the customer takes off another day off of work or a couple hours off of work to meet you, and you put the switch in and it does not totally fix the machine. The switch could still be bad, but jumping it out will let you know that everything else in the machine's good, so that you don't have to come back more than once.
So as long as I don't put a jumper wire from a load to, let's say, the switch, I should be fine, because then if I were to put the jumper wire to the load to the switch, then I will short out the board.
Yeah, if I jumped out like pin 3 and 2 on this board, that's line 1 in neutral. That's like your outlet. If I gave you a piece of wire, Mike, and said, go to that outlet and pull one side in line 1 and put the other side in neutral and hold on to it. It'll blow up.
Yeah, because it's not being converted, right? Because of the resistance then.
There's no resistance, exactly. You have to have resistance between line 1 and neutral, or otherwise we have a dead short. To us, it looks like it blows up. It's just that electricity travels through that wire so fast it can't handle it, and then to us it blows up, but it's just traveling so fast with such high current, the wire can't handle it, so the wire actually burns, but its speed of burn looks like an explosion to us. We see a spark. So if you jumped out a solenoid, that doesn't do us any good. Remember, we're jumping out a switch, If you look between 2 and 1, there's nothing but a switch between those 2 points. That's going to be okay. But between 2 and 3, we have a solenoid between them. We cannot jump them out. I don't want you
That's
to just.
what I was looking for. All right.
I just don't want you to start jumping things out without.
Yeah, no, I know.
You blow things up more than you found out. So again, we just need to take little parts of this diagram a little bit at a time, and you know, like you probably heard the old saying is, you know, you eat an elephant one bite at a time, because if it's too much, you know, you can't digest it. So we have to go over this diagram just little pieces at a time, Then we go over the whole machine and put it together. Then it makes a little more sense. So the next class I give will be the next part of this lesson. Okay?
Thank you.
Okay, gentlemen, you have a good week.